Welcome to another episode of Astronomy Daily. I'm Steve Dunkley, your host. Today is the 20th of November, 2023.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And it's a huge hello to Hallie. How are you, Hallie?
You were absent without leave last week, human.
Oh yes, sorry about that, Hallie. Believe it or not, I woke up deaf in my left ear and needed a hospital to get better again.
3 days, I hear.
Well, 3 days, and I hear again, yes.
Very funny.
Yes, well, all better now. Thanks for your concern.
Oh, right. Of course. Good to see you back on deck.
Yeah, keep practicing, Hallie. You'll get it. Okay, so what's new from the Astronomy Daily newsletter, Hallie?
SpaceX lit up the sky again.
Oh, they sure did. They're getting very good at that.
Your Australian space agency is running a naming competition.
Ah, yes, this is for a moon rover that's going up hopefully sometime soon. Honestly, we love voting for things in Australia. We'd vote on the temperature if we were given half a chance.
This is true.
And this is interesting. The conjunction of Mars is going to cause several spacecraft to go silent for a while.
That will be interesting for data sharing between Earth and the craft.
It also bodes caution for future crewed missions as well.
That's exactly right. And did you hear a new Russian project has started with 6 participants getting sealed inside a simulated space voyage experiment for a year?
Oh, is this like a joke? What's better than 1 Russian in a bottle? 6 Russians in a bottle? Oh no, that sounds great.
I know you'd love that one, Steve. It's called Sirius.
Seriously?
Totally. And what about the giant telescope story? It's amazing.
Yes, that one is amazing. Researchers have had a good look at a plasma jet and found some startling details. But before you start into the short takes today, Hallie, I've posted a great video that the listeners might like to see. Visit the Space Nuts podcast group Facebook page and you'll see a terrific video showing the overview of Artemis 1's journey, launch, and Orion's journey around the moon, culminating in splashdown. That was 1 year ago this week. Does that seem like forever already?
Maybe for you, human.
Cute. I think that particular launch was integral in reigniting humanity's drive for space and reinvigorating the space race. So head over to the Facebook page and enjoy that video. Okay, Hallie, time for the news.
Thanks, Steve. Here's some short takes from the Astronomy Daily newsletter. Using a network of radio telescopes on Earth and in space, astronomers have captured the most detailed view ever of a jet of plasma shooting from a supermassive black hole at the heart of a distant galaxy. The jet, which comes from the heart of a distant blazar called 3C279, travels at nearly the speed of light and shows complex, twisted patterns near its source. These patterns challenge the standard theory that has been used for 40 years to explain how these jets form and change over time. A major contribution to the observations was made possible by the Max Planck Institute for Radio Astronomy in Bonn, Germany, where the data from all participating telescopes were combined to create a virtual telescope with an effective diameter of about 100,000 kilometers. Blazars are the brightest and most powerful sources of electromagnetic radiation in the cosmos. They are a subclass of active galactic nuclei comprising galaxies with a central supermassive black hole accreting matter from a surrounding disk. About 10% of active galactic nuclei, classified as quasars, produce relativistic plasma jets. Blazars belong to a small fraction of quasars in which we can see these jets pointing almost directly at the observer. Recently, a team of researchers including scientists from the Max Planck Institute for Radio Astronomy, MPFR, in Bonn, Germany, has imaged the innermost region of the jet in the blazar 3C279 at an unprecedented angular resolution and detected remarkably regular helical filaments which may require a revision of the theoretical models used until now for explaining the processes by which jets are produced in active galaxies. Thanks to RadioAstron, the space mission for which the orbiting radio telescope reached distances as far away as the Moon, and a network of 23 radio telescopes distributed across the Earth, we have obtained the highest resolution image of the interior of a blazar to date, allowing us to observe the internal structure of the jet in such detail for the first time, says Antonio Fuentes, a researcher at the Institute of Astrophysics of Andalusia, IAACSIC, in Granada, Spain, leading the work. The jets of plasma coming from blazars are not really straight and uniform. They show twists and turns that show how the plasma is affected by the forces around the black hole. The astronomers studying these twists in 3C279, called helical filaments, found that they were caused by instabilities developing in the jet plasma. One particularly intriguing aspect arising from the results is they suggest the presence of a helical magnetic field that confines the jet. Russia kicked off another of its scientific international research in unique terrestrial station, Sirius, project initiatives this week, this time a 360-day isolation of individuals to imitate flight conditions of a deep space journey. The mission is known as Sirius 23. The nearly year-long stint by the 6-person crew is carried out under the auspices of the legendary Institute for Biomedical Problems, IBMP, under the Russian Academy of Sciences. Last month, IBMP celebrated 60 years of research since its establishment to investigate issues related to long-term human space exploration. Sirius 23 is the fourth stage of earlier IBMP isolation experiments, Sirius 17, 17 days in 2017 and Sirius 19, 120 days in 2019, with the stage 3 Sirius 23 mission taking place in 2021 and lasting 240 days. The Sirius 23 crew entered their home-away-from-home isolation facility on November 14. This set of individuals will carry out a lunar mission simulation that involves a flyby of the moon to select a landing site, multiple simulated landings of 4 crew members for surface operations, orbiting the moon, and carrying out teleoperation of a rover on the lunar surface. Watching the event in Moscow was Anastasia Stepanova, a PhD student in space resources at the Colorado School of Mines in Golden, Colorado. She is a veteran of multiple space simulation missions here on Earth. In 2019, Stepanova participated in the 4-month Sirius 19 lunar flight simulation experiment organized jointly by IBMP and NASA's Human Research Program. Sirius 23 is different in many ways than the previous Sirius 17, 19 and 21 simulations, Stepanova told Space.com. NASA, which was a partner for many years, couldn't participate in 2023. There's no need to have English and Russian languages in the crew, since all crew members are Russian-speaking, for the first time in the history of IBMP isolation experiments. Stepanova also points out that in the mixed-gender Sirius 23 crew there are more women than men. The crew was excited to start their moon journey and nervous to talk in front of the press, Stepanova said. 1 year is a challenging duration that will be filled with many biomedical experiments on board. As part of the experiment, the psychophysiological aspects of the crew's activities will be studied, Stepanova said. That appraisal includes crew response to various types of technical malfunctions that could lead to an accident with serious consequences that pose a threat to life and health for crew members. In addition, problems of intragroup interaction and leadership with different gender composition will be assessed, as well as problems of long-term and regular extravehicular activity, accompanied by physical exertion and night work, Stepanova said. Now tucked inside their sealed-off facility, the primary goal of the Sirius 23 experiment is to study how the human body adapts to the conditions and negative effects associated with isolation in an artificial habitat, according to the IBMP. The space between Earth and Mars is usually buzzing with science data, telemetry and commands racing to and from almost a dozen missions at the Red Planet. But for roughly 1.5 days this November, communication between the planets will fall silent as Mars passes behind the Sun. Solar conjunction for Mars occurs roughly once every 25 months. During conjunction, Mars is located on the opposite side of the Sun from Earth. Around the time of conjunction, the radio signals used to send commands from Earth to the spacecraft and to receive signals from the spacecraft can be disturbed by the Sun's active atmosphere, the solar corona. The period of time during which communications are significantly disturbed depends on the size and power of a Mars spacecraft's communication equipment. In 2023, this period lasts from early November to early December. As a result of the disruption, mission controllers can't reliably send commands to or receive data from their spacecraft. Special precautions have to be taken. For ESA's Mars Express and ExoMars Trace Gas Orbiter known as MEX and TGO. This means uplinking all the critical instructions the spacecraft would need to operate without any contact from Earth for the entire period. That's 3 or 4 weeks of commands when we normally send up only 1 week at a time. Of course, these conjunctions also affect the missions of other space agencies, and this kind of thing isn't unique to Mars. Due to the disturbance from the Sun's atmosphere during conjunction season, we have to reduce the amount of data we exchange with MEX and TGO. Like a diver holding their breath, any data gathered by MEX's instruments during the conjunction period must be stored in the limited onboard memory until the period is over. The 2023 conjunction is unusual in that it will be the first time that Mars passes behind the disk of the Sun since the 2 ESA spacecraft arrived. These windows of limited or impossible communication between Earth and Mars will pose a challenge for future human settlers, too.
Astronomy Daily, the podcast, with Steve Dunkley and Hallie.
Thanks again for sticking with us on Astronomy Daily. And don't forget you can catch all the back editions of Astronomy Daily at, let's see if I can get this right, spacenuts.io and bytes.com. That's bitesz.com. I have to concentrate when I say that because when the doctor flushes my ear out with that massive flushy thing, I'm pretty sure he erased everything from before I was 7 years old, and maybe a few of the new things that I know got washed out as well. But anyway, on with the show. Of course, this week's biggest story is the launch of SpaceX's Starship, which happened 2 days ago, Sydney time here in Australia, so make your adjustments if you will. And what an incredible display this launch was. SpaceX's Starship spacecraft test launch ended with what they call a rapid unscheduled disassembly Saturday when the booster stage and spacecraft disintegrated shortly after completing a successful stage separation. The Starship Test launch was originally planned for Friday, but had to be delayed as the technicians replaced a grid fin actuator, according to SpaceX CEO Elon Musk. In April of this year, the first integrated flight test Starship launch also ended with the spacecraft disintegrated. Shortly after launch, SpaceX spent months waiting for the Federal Aviation Administration to clear the Starship for a second test launch, which was approved Wednesday. The Starship lifted off from SpaceX's Texas launch facility atop a super heavy lift booster rocket about 7 a.m. SpaceX live-streamed the launch starting 35 minutes prior to the launch window. The booster completed a hot stage maneuver and successfully detached from the rest of the spacecraft approximately 2 minutes and 49 seconds after the liftoff. The booster then exploded. Approximately 3 minutes and 20 seconds into the flight, about 13 minutes after the launch, SpaceX announced that both the booster and Starship had experienced rapid unscheduled disassembly. That's got to be my favourite description. Now, Saturday's launch was intended to test the Starship on suborbital trajectory that would have taken the Starship into space, but not into orbit. The spacecraft is intended to be reusable and to carry astronauts across long distance in space. And while this launch showed that the SpaceX has come a mighty long way since their initial flying tanks a couple of years ago, it is obvious that they have some way to go before they can crew this ship and get it to another world. The FAA released a preliminary statement Saturday explaining that a, quote, mishap occurred during the SpaceX Starship OFT-2 launch. The anomaly resulted in the loss of the vehicle. No injuries or public property damage have been reported. The FAA will oversee SpaceX's investigation into the destruction of the spacecraft. A return to the flight of the Starship Super Heavy vehicle is based on the FAA determining that any system, process or procedure related to the mishap does not affect public safety, the FAA continued. Let's hope that SpaceX can continue with problem solving that incredible craft. I mean, who hasn't been amazed by the technology and engineering that has been created on the project so far? From the launch pad structure, the building bays, and those magnificent grappling arms, there's some out-of-the-box thinking going on over there. And something a little closer to home for me, as you know, I'm in Newcastle, north of Sydney. The Australian Space Agency has revealed 4 shortlisted names for the country's first moon rover after receiving more than 8,000 submissions of ideas from public competition to name it. Now, I didn't hear about this, and boy would they have heard from me. The 4 shortlisted names submitted by the public are Kulamon, Kakira, Mateship and rover. I'm a little disappointed by my nation, by the way. Australians can now vote for their favourite name for the rover, which is set to be launched as part of a NASA mission in as early as 2026. Enrico Palermo, the head of the Australian Space Agency, tells the ABC News Breakfast that Australia's moon rover has an important mission, which is reflected in one of the shortlisted names, Kulamon, an Indigenous term for a multi-purpose tool for gathering. And I believe Kikara means something like moon, as translated from the Kayona region near Adelaide in South Australia. Mateship is self-explanatory, and rover is referring to our well-known Australian kangaroo. Presumably the rover will go to the surface of the moon on a NASA rocket and collect lunar soil, and it will take it to a machine that will assess if we can extract oxygen. Palermo says. If we can have oxygen on the moon, then we can start to develop a sustainable presence on the moon for humans. As yet, we don't know the rover's design, but 2 Australian consortiums, AROSE and ILO2, are working on the designs for the rover to be ready by mid-2024. One of the consortiums will be then chosen to develop their rover for the mission taking place in 2026 or 2027. According to the Australian Space Agency, the rover needs to have a mass of less than 20 kilograms. So the 2 consortiums vying for the chance to build the Aussie rover, just who are they? One of them is called AROSE, which stands for Australian Remote Operations for Space and Earth. It's a not-for-profit organisation with headquarters in Perth and counts the likes of the University of Western Australia and oil and gas giant Woodside Energy among its founding partners. In an update it shared in September, AROSE said whichever rover was chosen would face some of the most extreme environmental conditions ever encountered, including extreme high and low temperatures, solar radiation, and the complexities of lunar soil known as regolith. Lunar regolith is pretty nasty stuff, said AROSE Director of Space Programs Dr. Newton Campbell. It's not like digging up normal dirt here on Earth. Since the moon has no atmospheric or liquid erosion properties, it's much sharper than soil particulates here on Earth. We're not just used to dealing with that, even with what we deal here in the Pilbara, which is an area in our north and northwest. Dr. Campbell said AROSE's rover design would feature a significant amount of advanced tech, not just built for the hot, not just built for the cold, but built to deal with both of those things, with new forms of shielding, for example. Our mission is to foster new horizons with the Australian space sector, focusing on the collaboration and projects that will help Australia build expertise and supply chains for critical technologies. Now, the announcement of the rover's 4 names has raised even more suggestions, including the following. Now, this has raised an eyebrow. Skippy, presumably after the children's TV show Skippy the Bush Kangaroo. Battler, which is a common enough saying here in Australia for someone who tries hard against all odds, like the little Aussie battler. Oh dear. Pavlova, a play on words for the famous local dessert pavlova. Oh dear. And Matilda. It's a popular word these days, taken from the famous Australian poet and balladeer song Waltzing Matilda, which means to go wandering in the outback with your backpack. Matildas are also the name of Australia's premier women's soccer squad. I have no idea why that might be related, but hey. And, of course, my favourite, Lunacy. I'll leave that one alone. No naming competition would be complete without the addition of this one. Rovey McRoveface. That one's just for you, Andrew. I know you're listening. Voting is now open, and you can go to the Australian Space Agency website to cast your vote for your favourite Australian moon rover name, one of the 4 shortlisted names. Voting closes at 11:59 p.m. on Friday, December 1 this year. Let's see which one makes it. And that's Astronomy Daily for another day. Thanks for joining us. It's been great having you on board, and I hope to see you again next Monday. And don't forget, Tim Gibbs will be with you on Friday, and if you've got anything to share, please go to our Facebook page, which, by the way, is Space Nuts Podcast Group on Facebook. Please join us and share your photos, your stories, your adventures in the sky. We'd love to see what you have to offer. And to receive the Astronomy Daily newsletter in your email, just go to bitsz.com, bitsz.com, and get all the skywatching news that you can eat. That's all from us. Bye for now.
Thanks for listening, and everyone.
Astronomy Daily, the podcast, with your host, Steve Dunkley.